Hi there, 7th graders. It's Mrs. Trombley, and it's finally time to put everything that we have learned together into one. This isn't exactly a note set in your book. This I just thought we had a need for, something to go back and put everything together because we have learned a lot of rules in the last few weeks. So we're going to start off with just a little bit of a summary, and then we're going to apply what we have learned about integers to order of operations and a substitution. So this one's a doozy. Buckle up. First off, integer rule summary. This will be a nice thing to have to look back to because all of the rules are all put into one place. So in the rules for addition, you've already learned that if you have the same signs, you add normally and keep the sign. That means that a -8 plus a -4 is a -12. It's not the same as multiplication. Same signs with multiplication means something else, but with addition, if you have 8 negatives and 4 more negatives, they're still negative. You also learn that when you're adding unlike signs, you subtract the digits and take the sign of the greater digit because you're making those zero pairs. So in this problem here, 8 minus 4 is 4. It'd be negative because I have more negatives to start. If I have a +8 plus a -4, it would be a +4 because I have more positives to start. So it's not automatically negative with addition. It depends on what you have more of because you're making those zero pairs. All right, subtraction, you learn that you can change every single subtraction problem to addition and use those rules by doing keep, change, change. So step 1 says leave the first number alone. Step 2, change subtraction to addition. Step 3, change the sign of the number that follows. And step 4, use your addition rules. So -5 minus 7 is really -5 plus -7. Same signs, add the digits, keep the sign. -5 minus -7, keep, change, change, would become -5 plus a +7. And when you have two unlike signs with addition, you learn that you subtract and take the sign of whatever you have more of. Finally, your multiplication rules and division. I put them both together because the rules are exactly the same. You don't have to change anything about the problem. With subtraction, it got its own little column here because we are changing something about it. With multiplication and division, we're not changing any signs. We just know that you multiply and divide normally, and two of the same sign means the answer is positive. So a -3 times a -4, 3 times 4 is 12, negative times a negative is a positive. 18 divided by 9 is 2, a negative divided by a negative is a positive. You've also learned that when you multiply or divide two digits with unlike signs, the value will always be negative. It doesn't matter which one's greater. So 5 times 7 is 35. One of each means it's negative. 27 divided by 9 is 3. One of each means it's negative. So there's a nice little summary of sections 1-2 to 1-5. Now, order of operations. You've already in your skill packets reviewed order of operations. And this was before you learned to change any signs or do any of that. Order of operations hasn't changed. What you do with subtraction has, and the fact that you're going to be having some negative values in there, that's going to be changing. So we can still remember PEMDAS, or please excuse my dear Aunt Sally, solve everything in parentheses first, simplify any exponents, multiply and divide from left to right. You don't always multiply before you divide. Those are both equal to one another. It's whatever happens first. Same with addition and subtraction, left to right. And you also know that substitution refers to replacing a variable with the amount it actually represents so that you can answer the question, so that you can evaluate it. So we're going to use these two concepts and all of our integer rules to do a bunch of practice problems. I know you're so looking forward to it, I'm sure. Anytime throughout this that you want to pause me, go ahead and turn your page. Anytime you want to press pause and try one of these on your own and then unpause it and see if you got it right, that would be a great idea. I mean, I will give you some practice in class. We'll be doing lots of practice with it. But right now, if you feel like you kind of got a handle on stuff and you want to pause as we go, great plan. All right, first of all, with these, there's no substitution. We're just supposed to evaluate. Now you've learned that subtraction changes to addition, right? So before you start solving any of these, because we have integer expressions here, there's positives and negatives, you're going to want to change your subtraction to addition. So I'm going to rewrite any subtraction that I see. So -5 minus 12 divided by 3, my first step is going to be to change this subtraction. So leave what you start with alone, change subtraction to addition, change the sign of the number that follows, and then I'm going to rewrite the rest of this problem. There isn't subtraction anywhere else. I don't make that a -3. I only change the sign of the number that follows the subtraction sign, and that's it. Okay, in looking at this problem, you might immediately want to take -5 plus -12 and then divide by 3. You can't do that. Order of operations comes into play. So, starting with P, there aren't any parentheses, we're good. There aren't any exponents, we're good. The next step would be to solve any multiplication and division that you see. That happens before we can add. So your next step needs to be to do this -12 divided by 3. -12 divided by 3. 12 divided by 3 is 4. A negative and a positive when you divide is a negative. So the result of that's -4. I still have my -5. I'm going to drop that down in front where it was. -5 plus -4. When you add and you have the same sign, you add normally. 5 plus 4 is 9. And you keep the sign. So voila. So again, you can't just go from left to right. You have to follow order of operations in every single one of these problems. Okay, let's take a look at the next one. Step 1, keep, change wherever you need to. The keep, change looks like it's going to take place here. So this -8, nothing's going to change about that. I'm multiplying that by 7, nothing changes about that. Here's my subtraction. When you are doing subtraction, we left the number in front of it alone. We're changing subtraction to addition. I'm going to change this positive 33 to a -33. And I'm going to leave the rest of this alone. I'm not going to change the sign of that because this is following a division sign, not a subtraction sign. Order of operations says solve anything inside parentheses first. This is just one single digit inside parentheses. There's nothing to solve in there, so we're good. There aren't any exponents. Great. The next, multiplication division, the MD in PEMDAS says do multiplication and division from left to right. So I see here that we have a multiplication problem. -8 times 7. That's a -56. You have one of each, it's automatically negative. I'm just going to rewrite the rest of this. It's just good practice to do that. Now I need to solve, again, this division problem before I can add. So I still have -56. -33 divided by -11. 33 divided by 11 is 3. A negative divided by a negative is a positive. So this is what's left. I see I have one of each and I'm adding. That means subtract the digits and take the sign of whatever you have more of. We have more negatives than positives. That means my answer is a -53. All right, moving along. There's subtraction here, so I'm going to leave the -11 alone. Change the subtraction to addition. Change the sign of the digit that follows. And leave everything else alone. Okay? All right, now there aren't any parentheses, right? No parentheses there, but I do see an exponent. That's what would happen next. Now remember in the multiplication, you learned that if I don't have the quantity of the -3, that it means the opposite of that. So with this problem, I know this is kind of tricky. I want to take care of this little piece first. I want the opposite of whatever 3 to the 3rd power is. 3 to the 3rd power means 3 times 3 times 3, which is not 9, right? It doesn't mean 3 times 3. It means I have my base 3 times. So 3 times 3 is 9. What's 9 times 3? That's 27. So when I rewrite this, I have -11 plus the opposite of 3 to the 3rd power, which we said was 27, divided by 9. I know, that one was a toughie. All right, at this point, I'm going to look for any multiplication and division. I see division right here. That has to be solved before I can add. So I'm going to bring down this -11 plus, and a -27 divided by a +9 gives me a -3. I'm left with a -11 plus a -3, which is -14. Voila. Okay, last one of this, and then we'll get into substitution. I told you this was a heftier one. I know, we're applying everything at one time. It makes it tougher. Step 1, remember to do all your keep, changing. So here's my -6 that I start with. I want to change subtraction to addition and change the sign of the number that follows. There's subtraction in here, so leave the number in front of the subtraction sign alone. And I want to change that to addition, and this 7 becomes a negative 7 squared. So that's the problem written as all addition. Now, order of operations. Take it step by step. We're supposed to solve anything inside parentheses first. So that means we need to solve 5 plus negative 7. I'm going to rewrite the rest of this right now. 5 plus negative 7, subtract, take the sign of the greater digit, leaves me with this. So we just simplified the parenthesis part. According to order of operations, my next step should be exponents. That means that I need to do the quantity of negative 2 squared before I do anything else. Okay? So the quantity of negative 2 squared, I'm going to put a little arrow over here. Remember that when I have it in parentheses, because this was in parentheses to start, it's going to stay in parentheses. That means I have a negative 2 multiplied by another negative 2. When you multiply two negatives, you get a positive. So the result of the quantity of negative 2 squared is a positive 4. That means now I have negative 6 plus negative 2 times 4. Because again, a number next to parentheses means multiplication. Now I know that so many of you want to take negative 6 plus negative 2 right now. But the thing is, you're not allowed to add before you multiply. So your next step needs to be to multiply this negative 2 times 4. So what you're left now with is negative 6 plus, when you multiply one of each, it's negative, and 2 times 4 is 8. So negative 6 plus negative 8. Now, when I add two negatives, I add the digits normally, and my answer is negative. So again, you get another negative 14. I didn't even do that on purpose, it just happened. Okay, now let's talk a little bit about substitution. Hopefully these will go a little bit quicker. We'll see. I know sometimes I'm kind of long-winded. So I ask you to evaluate each one. A is 3, B is negative 6, and C is negative 2. That means you're going to replace the letters with those numbers wherever you see them. And the thing about this is when I tell you that B is negative 6, we're going to assume that that means the quantity of negative 6. And that'll make a big deal when you have exponents. So I would just get into the habit of whenever you substitute a negative number in, I would wrap it up in parentheses. Because I don't want C to be anything other than a negative 2. The negative's going to stay with it. So you're not going to see B equals the quantity of negative 6. It's assumed that you'll know that. But I find that we should never assume, so I wanted to spill the beans and inform you of that. Alright, with this, don't do any keep changing until we have the numbers in there. It will make it a lot easier for you in the long run, I promise. So I want to know what 6 minus C is. That means I need to plug negative 2 in for the C. So I'm going to rewrite this as 6 minus, and C is negative 2. I told you when you plug the negative value in there, put the parentheses with it. Now I can go ahead and do my keep changing. This means 6 plus, and that was a negative 2, now it's a positive 2. So 6 plus 2, 8. Done with that one. Alright, this next one, I have absolute value symbols in there. That's okay. You learned how to attack those kinds of problems. Every time I say attack a problem, it just sounds scary, but I just mean solve it. So I'm going to leave those absolute value symbols in and plug my values in. So C is negative 2, and I'm supposed to subtract B, which is negative 6, and take the absolute value of it. You can kind of look at those brackets as you would parentheses. We want to solve that part first. I see subtraction here, so I'm going to keep, change, and I still have my absolute value symbols on the outside. And again, look at these brackets like parentheses. So that means I want to solve this. So negative 2 plus 6. That gives me a positive 4. So to get my final answer, I need to know what is the absolute value of 4. How far away from 0 is 4? It's 4 away. So that's my answer, 4. Alright, this one looks kind of crazy. It's not too crazy. Let's plug our values in. So negative 2 next to B, next to C, that means all multiplication. Number next to a letter means you're multiplying them. So we said that B was negative 6, C was negative 2. I'm not going to change anything yet. None of my signs get changed yet. Minus 3, and then I have C, which is negative 2, minus B, which is negative 6. Okay, at this point, we can go ahead and change our subtraction to addition. So I'm going to rewrite everything else. I have negative 2 times negative 6 times negative 2. And this has minus 3. Okay? So I'm going to change this subtraction to addition. I didn't change any signs of anything in front of it. You keep what you start with. But I want to add, and this 3 is going to become a negative 3. And in parentheses here, I have negative 2, and it says minus negative 6. That means plus, and it was a negative 6, I'm going to make it a positive 6. Now, we can go ahead and work on this. Order of operations says I want to solve everything in parentheses first. So these are just single digits inside parentheses, so there's nothing to solve there. But this set of parentheses actually has a problem in it. So I'm going to rewrite everything else. And now I want to take negative 2 plus 6. Two different signs when you're adding means subtract the digit. 6 minus 2 is 4. Take the sign of the greater digit. Good. Okay, order of operations says that exponents would be next. I don't have any of those. Then we have multiplication and division from left to right. I do have some of that. So I'm just going to solve all this from left to right. Negative 2 times negative 6, that's 12, right? So I have 12 times negative 2 plus negative 3 times 4. Now I do know that I need to do all multiplication before I can add anything, and all that's left is multiplication and addition. So I'm going to go ahead and take 12 times negative 2, which is negative 24, and negative 3 times 4, which is negative 12, and go ahead and add those results together. When you add two negatives, you add the digits, so 24 plus 12 is 36, and you keep the sign. So we get a negative 36. All right, there's more, I know, but this topic, it's kind of hard, right? There's a lot to do, so we need to do a lot of examples for this one. My apologies. Okay. These ones look a little different because I have some division wrapped up in here, and we haven't really had to do much with that. So it's the same thing. I'm asking you to evaluate when a equals negative 18. I'm going to wrap that up now. And b equals negative 6. Wrap that up in parentheses as well. Okay, so a plus 6 divided by 3, step 1. Let's go ahead and plug those numbers in. So a is negative 18. I'm supposed to add 6 to that and divide by 3. Now with this, I know that you've learned that you're supposed to divide before you add. However, when you have a fractional problem written, you need to solve the top, then solve the bottom, and then divide last. So that's why these are a little different than the rest. So what I mean is, for now, look at this as two separate things. Here's the top. With the top, I don't have anything inside parentheses to solve. There's just a single digit there. And then I don't have any exponents. I don't have multiplication or division. I just have addition left over. So when you add opposite signs, you subtract the digits and take the sign of the greater digit. Now looking at the bottom, there's just a 3 there. There's nothing to do, so I'm just going to write negative 12 over 3. And we already learned how to solve those. This just means a negative 12 divided by a positive 3. When you divide integers, you're going to divide normally, so 12 divided by 3 is 4. And when you have one of each, it means it's negative. So that one is done. All right, next, let's plug the values in. I have b squared over a. Remember that I want to keep that b is a negative 6, so I'm going to plug in the quantity of negative 6 squared over a is negative 18 plus 4. Okay, so looking at the fractional ones, I want to solve the top, solve the bottom, and then divide. So the quantity of negative 6 squared, that means a negative 6 multiplied by another negative 6. The parentheses keep the negative together. They keep it with the digit. So a negative times a negative is a positive, and 6 times 6 is 36. This negative 18 hasn't changed, and I still have plus 4. This is division. Division happens before you add. So when you take 36 divided by negative 18, 18 goes into 36 twice. When you divide, you have one of each. It's negative, and I still have plus 4. Negative 2 plus 4, that's 2. All right, last one like this. I have a minus 3b. Remember, before you do any keep, change, and let's plug values in. So we said a was negative 18 minus b is negative 6. And the number next to the letter means multiplication. Now we can do keep, change. This negative 18 is going to stay. I'm going to change this subtraction to addition. That 3 becomes a negative 3. I rewrite the rest of the problem. You cannot do negative 18 plus negative 3 first. Order of operations says that you need to do all multiplication and division before you can add. So what's left here is a negative 18 plus the result of negative 3 times negative 6. Remember, same signs, positive, multiply normally. So we're left with another little additive inverse here. Negative 18 plus positive 18, yes, gives you 0. So we did all that for nothing. So sad. Right, last one here. I ask you to evaluate 10 minus x squared divided by y when x equals negative 8 and y equals negative 4 on the grand finale. Remember, if I say x equals negative 8, that means the quantity of negative 8. And y equals negative 4 means the quantity of negative 4. Do that when you're plugging them in. So step 1, plug them in. 10 minus the quantity of negative 8 squared divided by, and y is negative 4. Okay, now this is where the confusion can kind of set in, because here's subtraction, and I told you we're supposed to keep change, right? So this is a negative 8 squared, the quantity of negative 8 squared, and before I can actually do this subtraction, which we're going to change to addition, I need to take care of this. What I would actually recommend, if you see that you have a negative base, the quantity of a negative base raised to a power, I'd recommend that you solve that first, because what's really happening here is you're taking 10 plus the opposite of that. So if you were to rewrite it, this is why I'd include all these in here, all these little tidbits of information, it would look like this. I'm hoping this makes sense. There's other ways to do this. I'm trying to get you to kind of conceptually understand what we're doing here. That's why I just didn't write 10 plus a positive. You get the same result, because when you take a negative 8 and raise it to an even power, it's going to become a positive anyhow. But this is kind of what it means. So according to order of operations, since there's nothing inside the parentheses, there's only single digits in there, you would need to do exponents next. So that means I want to raise the quantity of negative 8 to the second power. So I'd have 10 plus, and then I have the opposite of, a negative 8 squared means negative 8 times negative 8. That's 64, right? But I want the opposite of 64, so that means it'd be a negative 64. Crazy, I know. Then I want to divide that by a negative 4. Okay, so I can't just add. I need to do my division first. I'm running out of room, so that means we have to be done soon, right? I need to do a negative 64 divided by a negative 4 and add 10. So 64 divided by 4, if you look at that and you're not sure what it is, you can do this a long way. You can say, well, 64 divided by 4, right? 4 goes into 6 once. There's 2 left over. Drop down the 4. 4 goes into 24 6 times. I have no remainder. So that means that 64 divided by 4 is 16, and a negative divided by a negative is a positive. You're left with 10 plus 16, which is 26. I promise you we will do more practice with that. Hopefully we have a nice start to it. I'll see you tomorrow.